Hello and greetings. This is the third question of October-November 2025 paper. October-November paper 3 variant 2. So in question number 3, they have a shaded region in the organ diagram bounded by a line, and a circle represents a complex number z, that is imaginary number satisfying, and the point shown on the diagram E, one of the intersection on the line. Find the complex number represented by P. Given answer must be in the form of x plus iota y. So where x and y are the real and exact values. For this, we need to know first thing the value. We know by our basics that a minus x minus a whole square plus y minus p whole square would be equal to the radius. In this particular case, when the center is AB. So in this particular case, we can see that this point is the radius, and radius, if you can see that if you want to go from here to here, like this is, if this is 1, so we can see that it would be 2. So the radius, and over here it's also given that its RE is less than or equal to 2. So if it's 2, that means the radius is 2. So radius can be easily given there. Now it's bounded by 3. So that means the value A means this value is A. So we can just plug in the values to find the variable y, because y is not given and we do have the A. And obviously B is not given here, but since we can check that iota, so this value over here is just can be considered as 1, so we can take this value. So there is another point of consideration that can be considered, like over here it's not equal to 4, but it should be. So yeah, if means 2 square would give you 4. So let's start the question. So at point P, we already have given, we have point P as 2, or we can say that x is 2. So y was not mentioned, but since we can write this equation, rewrite this equation like this also. Let me write it, z minus, it's already given, so there is no need for that, this equation. So this is r square, this 3 can be considered as x, and this iota, single iota, means if there would be 2 iota, so we would say that the value for b would be 2, but it's not, the coefficient of iota is just nothing, so we will say, we'll take that as 1. So now we can take that x would be 2 and y would be 1. So now we can just plug in the values. 2 minus a is just 3, and y is what we need to find out, and b is just 1 because of the iota's values. This was 2 square. So 2 minus 3 is just negative 1 square, positive y minus square. Let's just keep it as it is. And this would be 4. This would be positive 1. So let's take this as the value 4, and this would become 3. So y minus whole square, let me just take one more step, 4 minus 1, this would turn out to be y minus 1 whole square equals 3, and now we can take the square roots on both sides. So this would give us something as, because the root will go off, so y minus 1 equals to root of 3. And if I want to take the value of y, this would just give me, this would shift over there, 1 plus root of 3. So that would be the answer, and this would be positive and negative. So this would be, one value would be for positive value and one will be for negative, and that would be the case for this. Now moving on to part B. So part B, in this we need to get a shaded region. So find the greatest argument, like argument z, for the points of the shaded region. And for the points of the shaded region, you can see that we can consider a tangent, like starting from here, and we know that this radius would remain same if it touches any point on the tangent. So now we can observe that these values, for the first value, this would become a right angle triangle, and this value obviously is going to be the same. The radius is obviously 2, and if we are going to take the value for like the other part, so let me just take another one also for this part, and this would also turn out to be a right angle triangle. So for this part, we have this as 3 and this has just 1, because we know that it's moving towards the imaginary part, distance is 1. And for this we can find the hypotenuse square. So we know that Pythagoras theorem, hypotenuse square is equal to base square plus this. So hypotenuse is unknown in this case, and base is there's 3 square and 1 square. This would turn out to be 9 plus 1, 10, and this would be just hypotenuse square would turn out to be this. So this would be just 10. And for arguments, we can simply do the math that one angle could be written as theta and the other angle could be written as alpha, and this can be done by the sine rule, because the first triangle would be, let me just take this value from here and bring it down there. That would make sense. Okay. So we have this in front of us. So now we can observe that we can plug in our data of the argument. the greatest argument can be like there are two angles. One is considering this triangle theta, this would be just 3 here, 1 here, and this is under 2 under 10. So first would be sine. So um, sine of this, the no, that would be tan. This would be tan. And if we have another triangle, this one, that would be of alpha. So alpha would be, we have 2 here, and this was under root 10. So this would turn out to be sine. So we would just add up the both values. We would say that the greatest argument of z would be equal to sine inverse of 2 over 10 plus with tan inverse of 1 over 3. And when you do the math, when you plug in these values in the calculator, the answer directly would be let me just calculate it. So it gives us in radians. Make sure the calculator must be in radians. 101 radians. That would be the final solution for A and B for question number 3.